Now I have the center drill loaded up in the spindle, and I'm at my XY0 position. I'm going to go down 2 inches, and I'm going to come over 1 inch 250 thousandths. And I'll go ahead and lightly lock my table. Now, when I lock my table, if I see the readout change over at the 4th decimal place, it'll usually change by 0.5 or maybe 0.2 depending on which readout you're using. I'm going to actually ignore that, and it's going to be hard for you to do, but I want you to understand that for what we're doing, that level of accuracy isn't necessary, and so just please overlook it. You're going to spend a lot of time if you keep on chasing that 4th decimal place, and it doesn't apply to necessarily be needed with the tolerances we have on this part, so keep that in mind. Now what I'm really looking for here is when I bring down the tip of my drill, will it mark the exact center location that I scribed? So let's go ahead and turn it on and see. Now that looks good to me, so I'm going to go ahead and center drill this location here. Now, I just center drilled the location for the 1 inch hole, and we already talked about the 3/8 holes, tapped holes that are surrounding that. They're going to be in relationship to that hole. And I know that my pocket feature is also independent of all the features that are my hole features. So what I'm going to do is I'm actually just going to go ahead and zero out the readout at the center location. Now, there's a few tricks that could make this easier, but I want to keep it as simple as possible for now, and we're just going to zero out the readout where it is in its current position, and I will know now that I will go up 0.75, I will go over 0.75, I will center drill, and then I will go, and I'll be flipping back and forth in my coordinate system, and it'll go from positives to negatives, but I will always be on 0.750. And I'm going to center drill all the hole locations, so that way I know that my drill bit will not wander off of the exact location that I intend for the hole to be in. I'm also going to go ahead and add a little bit of cutting oil where the center drilling will take place. I had forgotten earlier because, well, I'm concentrating more on videotaping than I am on machining. I machine for a living, I don't make videos for a living, so this is a little bit out of my norm. So I'll go ahead and I'll move the table 0.750. That'll be positive in the y-axis, and there I am. And now I'm going to move in the x-axis 0.750. And there I am. Now I'll turn the spindle on and center drill that location. Now if I notice my tip was off of my intersection of my lines, which you may or may not be able to see on video, I would stop and investigate, because if I see something that looks wrong and I ignore it, well then I shouldn't be surprised later on when I have an error in my part. So here we go. I'm just going to drill all the holes and I'm not going to talk. Now, using the tap and drill charts, I have selected and located the correct drill bit. I verified the end of the drill bit was sharp and that it's in good working order. So now I'm going to go ahead and I'll dab a little bit of cutting oil where all the holes will be located, and while I'm drilling I will be pecking. That means I'm going to be feeding downwards, and as the chips come up the drill I will be backing away and relieving the pressure in an attempt to have the chips fall to the side instead of continually grow and get wrapped around the drill. Now, if they were to get wrapped around the drill, what I would do is stop the spindle, and I would use my 6-inch scale or a pen or pencil or something like that to flick them away. I want to avoid grabbing and pulling on the chips because there's a high probability that they could cut me, and I absolutely wouldn't want to try to grab at them while the drill bit was spinning. I've also made a correction in my RPM, and I used my feeds and speeds charts in order to figure out where I should be. Now, what you noticed there was the drill bit grabbed and it spun momentarily, so that means I didn't quite get the chuck tight enough. Or maybe there was a little bit of damage on the shank of that drill bit or on the jaws of the drill chuck. I'm not sure, but I went ahead, I stopped the spindle, and I tightened it back up. When you're breaking through a part, there's a high probability that a drill bit might tend to spin at that point. So I could have also relaxed and fed a little bit easier. Now I move into my y-axis to negative 0.750, and I've arrived at that location, so I'll drill my hole. Now, all my holes have been drilled, and before I tap, I'm going to go ahead and I'm going to switch drill bits. I'm going to drill the center hole location. The reason for that is I'm not going to tap in my drill chuck, so I don't want to change and take my drill chuck out to put the tap in to tap these holes, to put the drill chuck back in to drill this hole, and that would be adding another tool change. So you always want to be trying to think ahead, and as a new student, you're going to make a lot of mistakes where you're taking 2 steps forward, 1 step back. But as you gain experience, you'll be able to think far enough ahead and see little shortcuts, or they're not even shortcuts. You'll just see ways to be more efficient. Now I've switched to the larger 13/16 diameter drill bit as the print indicated I should, and I'm going to drill the hole. And I've also adjusted my RPM again to accommodate the difference in diameter. Now, we will always be using the RPM charts to figure out how fast we should go, but we're also going to have to use experience and a little bit of by the seat of our pants choices that we're going to have to be making. So if I were to actually calculate the correct RPM for this drill bit, what I would find is upon the starting of the drilling process, I would encounter a lot of chatter, and that would be primarily because the machine I'm using, the way that it mechanically works, and also my own operator level of being able to feed the drill at a fast enough feed rate to keep the chip load correct to where the drill won't want to just bounce around and chatter. So if you're ever drilling a hole and you find yourself with a very, very, very chattery sound when you're entering the hole, there's a good chance that you might be going a little bit too fast at that point in time, or you just need to kind of bear with it, because as soon as the full diameter of the drill bit enters the hole, it will stabilize. There's nothing but experience that can teach you these things. I can't just tell you a one-size-fits-all answer. So here we go. I put a little bit of cutting oil, I'm going to turn the spindle and drill the hole. Now we've got our hole drilled, we're in the XY0 position, so I'm going to go ahead and switch take out this drill bit, take out the drill chuck, and we're going to put the boring head in, and we're going to go ahead and bore this hole. Since again, we're at the position that the hole is going to be bored at. We've drilled all the other holes, so we're going to save steps, and we're going to just do finish the hole that we're in right now.